Complex modeling can be facilitated by using intersection of two or more objects. Intersection can be applied only between objects of the same class, such as intersection between curves, intersection between surface meshes, or intersection between surface primitives. Operation of intersection enables building a complex model, composed of simple objects. Let's make an example of intersection between multiple curves. Create a straight line and a circular arc, and lastly a closed spline curve. These three objects are placed on a plane, and share a number of intersection points. But, they are currently independent, as being selected by clicking each of them. In order to obtain intersection points, choose Intersect item from Edit menu. Intersect dialog pops up. There is a drop-down list to set the object class for intersection. That is, curve, surface mesh, and surface primitive. Set the class to curve, as we are working for the intersections between the three curves. Select all the three curves. And click Intersect button. 6 intersection points are determined, and marked by small circles. The intersection point splits each curve into a few independent curve segments. We may delete some of the segments as desired, by selecting them and pressing the Delete key. Adjacent curve segments are connected at their intersection points, and form closed regions, as identified by the region highlight. Delete all the existing curves. And, let's make a practical example of curve intersection, in creating a section of horseshoe shape. Draw a half circle for the crown of the horseshoe. 2 circular arcs for the side walls. And a circular arc for the bottom invert. Choose Intersect item from Edit menu. Select the curves and click Intersect button. 2 intersection points are obtained. The circular arcs are split by the intersection points. Select the extrusive segments of the circular arcs, and press Delete key. We obtained a clean horseshoe shape, by chopping off the redundant parts. This curve model with horseshoe shape, will be used in the next example of surface mesh intersection. The next part of this tutorial is about the intersection between surface meshes. A surface mesh will be generated, using the horseshoe-shaped curves we created just now. The first step is to specify the division of the curves determining the mesh density. Choose Divide item from Divide menu. Curve division dialog appears. Set the number of division to 30. Check Apply as a whole item. Click Divide button. The whole section of horseshoe shape is divided into 30 line elements. Rotate the display to get a 3-dimensional view of the model. Choose Extrude Surface item from Mesh menu. The Extrude Surface dialog pops up. Set the triangle arrangement to Union Jack, and the extruding direction to Z. The extrusion height to 60. Leave the number of divisions, 30, as it is. Click Generate button. A surface mesh is generated with a horseshoe-shaped cross-section. We need another surface mesh to apply surface mesh intersection. Let's create the second surface mesh by duplicating the first one with a certain angular offset. Choose Duplicate and Revolve item from Edit menu. Duplicate and Revolve dialog appears. Choose Surface Mesh Selection tool. Set the offset angle to 75 degree. Select the surface mesh and click Set Object button. The name of the button is turned into Set Axis. Thus, the next step is to determine the axis of revolution for mesh generation. The current option of axis setting is preset as Input. This option requires determining the axis of revolution by inputting the coordinates of its endpoints. Input 20, 0, and 30, respectively for the x, y and z coordinates of the first point, and 20, 50 and 30 for the second point of the axis. Now, the axis is displayed as a red line. Click Set Axis button. Then, the surface mesh is duplicated, and a new surface mesh is created with rotation of 75 degree. The central parts of the two surface meshes look overlapped, but they are separated with no connections. For surface mesh intersection, choose Intersect item from Edit menu. Intersect dialog pops up. The object class is automatically set to Surface Mesh because Surface Mesh Selection tool is already activated. Select the two surface meshes. Click Intersect button. Then, the intersection is being processed, and intersection curves are created between the two surface meshes. The intersection curves split each of the surface meshes into multiple meshes, and at the same time, form boundary lines compatible with adjacent surface meshes. The elements surrounding the intersection curves are regenerated to form the compatible boundaries. The surface meshes split by the intersection can be handled individually as independent objects. So, some of them can be deleted if necessary. In this example, it is necessary to delete the surface meshes blocking the passage through the two conduit spaces. Select the blocking patches and delete them. The first one in the front side. The second one in the rear side. The third one in the left side. And the last one in the right side. Now, two conduits are connected as an open space. For a better and simpler view, let's change the rendering mode to shading. The next example of surface mesh intersection will be presented as a process of building a three-dimensional solid model. In this example, the outer boundaries of the three-dimensional model are composed of rectangular surface meshes. After turning off YZ and XZ grid plane, create four straight lines forming a square on the XY plane. Select the four straight lines. And divide each of them into 20 line elements. In order to apply the same method of surface mesh generation as before, choose Extrude Surface item from Mesh menu. Extrude Surface Mesh Generation dialog pops up. Apply the same specification as before. That is, Union Jack for triangular arrangement, Z direction for extrusions, 60 for height, and 30 divisions. Select a straight line and click Generate button. A rectangular surface mesh is generated. Repeat the same procedure with the other three straight lines. Thus, the newly created surface meshes form a rectangular boundary walls surrounding the longitudinal conduit. To clarify the spatial relation of the meshes, change the rendering mode to Hidden Removed. The second conduit appears protruding out of the boundary wall. Protruding parts are redundant for the desired modeling. The selected surface mesh is not connected with the newly created meshes. Intersection of surface meshes makes it possible to remove the redundant parts, and make connections between the intersected surface meshes. Select Intersect item from Edit menu. Intersect dialog pops up. Select the surface meshes to intersect. Click Intersect button. The intersection curve is created, and surface meshes are split into parts by the intersection curve. Select the surface mesh, protruding out of the boxing mesh, and delete it. Delete another redundant mesh split by the intersection. Repeat the same procedure for the opposite side of the model. Select surface meshes. Perform intersection. Delete the redundant meshes. Rotate the screen view to make the redundant mesh part accessible. Select the surface mesh, split by the intersection, and press Delete key. It is necessary to cover the front and rear openings, to form a closed three-dimensional volume. This can easily be achieved by automatic generation of surface mesh. Choose Auto Mesh Surface item from Mesh menu. Auto Mesh Surface dialog pops up. Region Selection tool is automatically activated. Move the cursor over the mesh region, that is, the opening part. The region is highlighted in green color. Select the region by mouse clicking. Press Generate button. A surface mesh is generated. And the front opening is sealed by the mesh. Rotate the model view to repeat the same operation for the opposite side. Select the opening region, and generate the mesh. Now, a closed three-dimensional space is constructed. It is desired to fill this space with three-dimensional solid element. Choose Auto Mesh Volume, item from Mesh menu. Auto Mesh Volume dialog pops up. Select all the surface meshes by rubber banding. Click Generate Mesh button. Then, the closed space is filled with a three-dimensional solid mesh. The Volume Mesh Selection tool is enabled, which indicates the presence of the volume mesh. Click Clipping Plane tool to examine the inside of the volume mesh, composed of solid elements. The clipping plane shows the sectioned drawing of the solid elements. Change the rendering mode to shaded image. We may examine the contents of the generated solid elements, using clipping plane view. The last part of the tutorial is the intersection between surface primitives. This example uses a truncated cone and a sphere as the surface primitives for intersection. Let's first create the truncated cone. Input the axis of a cylinder with the radius of 1. The parameters of cylinder include two radii, that is, radius 1 and radius 2. Set them to 5 and 10, respectively. This defines a truncated cone, as a variation of cylinder. Let's define a sphere as the second object for intersection. Designate a grid point as the center of the sphere. And set the radius to 10. Choose Intersect item from Edit menu. Intersect dialog pops up. Click Surface Primitive Selection tool. Then, the class of object for intersection is automatically set to Surface Primitive, as shown in the drop-down list of the dialog. Select the truncated cone and sphere by rubber banding. Click Intersect button. Then, the intersection curve is determined. We may generate surface meshes on the surface primitives, using this intersection curve as boundary curve. Choose Auto Mesh over Surface Primitive item from Mesh menu. Then, Auto Mesh Primitive dialog pops up. At the same time, Surface Primitive Selection tool is automatically activated. Select the truncated cone by clicking it. Then, the mesh region is defined on the truncated cone, with the intersection curve as the boundary of the region. Click Generate Mesh button. Then, a surface mesh is generated on the region of the truncated cone. Let's define another mesh region on the sphere. Click a point on the sphere. The mesh region is marked in blue color. We may switch the mesh region to the other part, by changing the mesh part option to Outside. Click Generate Mesh button. A new surface mesh is created on the selected region. To simplify the display of the model, hide the surface primitive, by choosing Hide Primitive Surface item from View menu. In order to build a three-dimensional space, closed by surrounding surface meshes, let's seal the front and rear caps of the truncated cone. Choose Auto Mesh Surface item from Mesh menu. Auto Mesh Surface dialog pops up. And Region Selection tool is automatically turned on. Move the cursor over the mesh region. Then, the mesh region is highlighted in green color. Select the region by a mouse click. Double-click the region. Then, a new surface mesh covers the cap of the truncated cone. Rotate the model view. And repeat the same procedure on the opposite side of the cone. Now, the surface meshes form a closed three-dimensional space. The final step is to fill the three-dimensional space with solid elements. Choose Auto Mesh Volume item from Mesh menu. Auto Mesh Volume dialog pops up. Select all the surface meshes by rubber banding. Click Generate Mesh button. A three-dimensional solid mesh is created, and thus the Volume Mesh Selection tool is enabled. Change the rendering mode to shaded image. Activate the Clipping Plane tool, and examine the internal contents of the solid mesh. This is the end of the tutorial, about editing by intersection of curves, surface meshes and surface primitive.